Hello everyone! In our previous videos, we saw two types of experimental questions in stoichiometric relationships chapter. The first one was about the empirical and the molecular formula, and the second one was about the determining molar mass of an ideal gas. And this is the third video, and it is about determining the number of crystal water in a hydrated salt. And what do we mean by a hydrated salt? It's an ionic compound containing the crystal water. And how do we show their formula? Here we have an example in the question. We have hydrated sodium carbonate. So first we write the formula of the salt, and then we write the number of crystal water inside it. And we use a dot to represent it's a hydrated salt. X must be a whole number. And here it is given as X because it is the unknown in this question. And before we start solving the question, let me read it. A 5.880 grams sample of hydrated sodium carbonate was dissolved in water and made up to a total volume of 250 cm cube. Of this solution, 25 cm cube was titrated against 0.2 molar hydrochloric acid and 20.55 cm cube of the acid was required for neutralization. Determine the value of X in the formula of hydrated sodium carbonate. So we start solving the question by writing the equation when sodium carbonate hydrated is dissolved in water. Sodium carbonate and crystal water are separated from each other. And we have 5.880 grams of the hydrated salt, and these are now unknown. We don't know their masses, we don't know their number of moles. And you cannot calculate the number of moles of hydrated sodium carbonate because you don't know the number of water molecules inside the hydrated salt. Now, what do? We add water until the total volume becomes 250 cm cube, and then we take a smaller portion, 25 cm cube, for titration. We are not using 250 cm cube in titration because it's a huge volume and it will take a lot of time in titration. So it is better to continue with a smaller portion, which is 1/10 of the original solution. So we have 25 cm cube of sodium carbonate solution, and it is titrated against hydrochloric acid. It's a metal carbonate acid reaction, and it produces sodium chloride salt, carbon dioxide gas, and water liquid. And all others are aqueous in this equation. And to balance the equation, we put two coefficients to hydrochloric acid, and this shows the mole ratio between sodium carbonate and hydrochloric acid is 1:2, as you see from the coefficients. So what do we know from the question? We have 0.2 molar hydrochloric acid and 20.55 cm cube is required for neutralization. So you know the concentration of hydrochloric acid, which is 0.2 molar. And you know the volume, which is 20.55 cm cube. So we can calculate the number of moles of hydrochloric acid by multiplying these two values, but we need to be careful about the unit of the volume. We need to convert it into decimeter cube by dividing it to 1000. So the number of moles will be 0.2 molar times 20.55 divided by 1000, and the number of moles will be 4.11 times 10 to the power of minus 3 moles for hydrochloric acid. Now we can calculate the number of moles of sodium carbonate because the ratio is 1:2, so we need to divide this number into 2, and it will be 2.06 times 10 to the power of minus 3 moles of sodium carbonate in the smaller portion, which is 1/10 of the original solution. So if we have 2.06 times 10 to the power of minus 3 moles in 25 cm cube portion, then we need to multiply this number by 10 to find the number of moles in the original solution, which is 250 cm cube. So the number of moles of sodium carbonate in the original solution will be 2.06 times 10 to the power of minus 2 moles. So let me continue in the next page. We have 2.06 times 10 to the power of minus 2 moles of sodium carbonate. We don't know the number of moles of water yet. We know the mass of the hydrated salt. It is given in the question as 5.880 grams. So can we calculate the mass of sodium carbonate? Yes, we can, because we know the number of moles, and we can calculate the molar mass by using the atomic masses of sodium, carbon, and oxygen. Atomic mass of sodium is given as 22.99 times 2, since we have 2 sodium, and we have 1 carbon atom, which is 12.01, plus we have 3 oxygen atoms, we have 3 times 16, and in total it makes 105.99 grams per mole. Now we need to calculate the mass by multiplying these two numbers, number of moles and molar mass. So 2.06 times 10 to the power of minus 2 moles times 105.99 grams per mole. It gives us the mass of the sodium carbonate, which is 2.18 grams. And we know the total mass of the hydrated salt, so by using the law of conservation of mass, we can also calculate the mass of water, because the mass of reactants must be equal to the mass of the products. So 5.88 is equal to 2.18 plus, let's say A here, A, and A is equal to 3.70 grams. So we know the mass of water now, and can we calculate this number of moles? Yes, it's possible now because we know the molar mass of water. It is atomic mass of hydrogen is 1.01, so 2 times 101 plus, and atomic mass of oxygen is 16. In total it makes 18.02 grams per mole. So number of moles of water will be M over MR, mass over molar mass, and it is given as 3.70 divided by 18.02, and we find it as 0.205 moles. Now we know the number of moles of sodium carbonate, which is 0.0206 moles, and we know the number of moles of water, which is 0.205. And actually we know the ratio between the number of moles of sodium carbonate and water, it is 1 to X. So to determine X, we need to divide the number of moles of water to the number of moles of sodium carbonate. And this results as 10, and we find the number of moles of water here. If it is not a whole number, please just round it up to the closest whole number. And we can write the formula of the hydrated salt as sodium carbonate 10 hydrates. And this is all for today. If you have any further questions, please do not hesitate to send me an email. I will reply it as soon as possible. Thank you.